You're welcome back from break. Let's have the solution of the classwork. Let's consider the A part of question 1 of the classwork. Simplify the following. 12r raised to power 3 divided by 3r. This actually means 12r raised to power 3 divided by 3r, which is 3 times 4r raised to power 3 divided by 3 times r. This 3 will take care of this 3, so we have 4r raised to power 3. The r here is having power 1. The power 1 is here, invisible. But the moment we take it from this to let it take another form, then we indicate that power 1 for it to be easier to be attended to. So, minus 1. The power of the denominator will be subtracted from the power of the numerator. So, we have 4r raised to power 2. That is one way. Another way is by having 12 divided by 3 into r raised to power 3 divided by r raised to power 1. That's another way. 12 divided by 3 is 4 into r raised to power 3 minus 1. We use subtracting the indices here. 4r raised to power 2. This division sign changes to subtraction in the exponential region to subtract the indices. Subtract this from this. So the answers are in harmony. Let's look into the B part of the same classwork. 54 m raised to power 3 divided by 9m raised to power 2 could be expressed as 54 m raised to power 3 divided by 9 m raised to power 2. So which is 9 times 6 m raised to power 3 divided by 9 times m raised to power 2. This 9, we take care of this 9 to have 6 m raised to power 3 minus 2. We subtract the power at the denominator from the power at the numerator. So we have 6 m raised to power 1. Meanwhile, 6 m raised to power 1 is the same thing as 6 m. Or 54 m raised to power 3 divided by 9 m raised to power 2 could be 54 divided by 9 in bracket into m raised to power 3 divided by m raised to power 2. 54 divided by 9, that's 6, into m raised to power 3 minus 2. 6 m raised to power 1, that's 6 m. Do you understand? Good. Let's consider the C part of that question 1. Simplify 18y raised to power 7 divided by 30y raised to power 4, which is expressed as 18y raised to power 7 divided by 30y raised to power 4. And this is 3 times 6y raised to power 7 divided by 30 times y raised to power 4. 3 takes care of 3. We have 6y raised to power 7 minus 4. The power on the y at the denominator will be subtracted from the power at the numerator. 6y raised to power 3 is the answer. Or we have 18y raised to power 7 divided by 30y raised to power 4, which is 18 divided by 30 in bracket into y raised to power 7 divided by y raised to power 4. 18 divided by 3 is 6 into y raised to power 7 minus 4. Here we choose one of the common bases. Then we let the division sign change to subtraction at the exponential level. to subtract 4 from 7. Do you understand? So we have 6 into y raised to power 3, which is 6y raised to power 3. You can see that the answers are the same in both. Let's consider the question 2 and of course the last question of the classwork, which is divide 5.4x raised to power 8 by 1.8x raised to power 5. That means 5.4x raised to power 8 divided by 1.8x raised to power 5, which actually means see 5.4 and 1.8. 1.8 in 3 places is 5.4. So we have 3 times 1.8 x raised to power 8 divided by 1.8 x raised to power 5. This is rather written as 1.8 times 3 times x raised to power 8 divided by 1.8 times x raised to power 5. 1.8 we take care of 1.8. So we have 3x raised to power 8 minus 5, which is 3x raised to power 3. Do you understand? So that is it. Now we come to another subtitle under indices, which is law of zero power. What happens when the power of a particular number is 0? That whole system is equal to 1. So anything raised to power 0 is 1. Example 1. Simplify 3x raised to power 0, y raised to power 2 times 2y. So we know that this is 3 times x raised to power 0 times y raised to power 2 times 2 times y. So which is 3 times 2. I bring the figure together times 1. Where do I see the 1? This x raised to power 0 is 1 times y raised to power 2 times y raised to power 1. Do you understand? So 3 times 2 is 6 times 1 is still 6 times y raised to power 2 plus 1. Applying the law of adding the indices, adding the powers here, because they are of the same base, so you can add their power. 1 plus 2 is 3. 6y raised to power 3 is the final answer. Let's consider example 2. Simplify x y raised to power 0 times xy in bracket raised to power 0. As you can see, this is x times y raised to power 0 times xy in bracket raised to power 0. I rewrite by splitting this. So x is x times y raised to power 0 is 1, put 1, times xy in bracket, all raised to power 0, the whole bracket, everything inside the bracket equals 1, because the power 0 is on x, y together. Unlike here, where the power 0 is only on y, not on x. Here is on both x and y. So answer is x times 1 times 1, which is x. So x is the answer. That is it. Now we come to another important concept, which is law of negative power. Law of negative power is a concept that is very important in indices. Generally, when you have x raised to power c, it means 1 over x raised to power c. I've given you the hint at the beginning of this topic when we started about this. So, but when you have something like x over y, a fraction, we take this x as a whole number here, having negative power. It will be expressed as 1 over x raised to the power c. But when you have a fraction like x over y with negative power, let's say negative c as a power, in indices, we express it as y over x raised to power c. We find the inverse of the fraction, and that will inverse the arithmetic sign of the power as well. The arithmetic sign of this power is negative. The inverse of it will be positive. Since we inverse the fraction such that x over y becomes y over x, the arithmetic sign of the power also will be inversed. So it will be positive, which can now be expressed as y raised to power c over x raised to power c. Let's consider example 1 under it. Example 1. Simplify the following. Question here. 3 raised to power minus 1 is expressed as 1 over 3 raised to power 1. Can you see? The power 1 is still retained, which means 1 over 3, because 3 raised to power 1 is still 3. So that is why that is the answer. Question B. 5 raised to power negative 2 is expressed as 1 over 5 raised to power 2, which finally will be 1 over 25, because 5 raised to power 2 is 25. Question C. 4 raised to power negative 3 is first expressed as 1 over 4 raised to power 3, in line with the principle, which finally will become 4 raised to power 3 is 64. And that is it. Let's consider example 2. Simplify 3 over 4 in bracket raised to power negative 1 times one whole number 1 over 3. How do we address this? Remember, anytime you have fraction carrying negative power, find the inverse of that fraction. Inverse of 3 over 4 is 4 over 3. Now, raised to power positive of that power, not negative again. Negative 1 now will be positive 1 times, change one number 1 over 3 into improper fraction. That is 3 times 1, that's 3 plus 1, 4 over 3. So, when a number is raised to power 1, that means it's as good as not putting the power 1 there. So I can rewrite this as 4 over 3 without the power 1 on top, times 4 over 3. 4 times 4 is 16. 3 times 3, that is 9. 9 and 16 is 1. What remains? 7 over 9. And that is that. Let's look at example 3. Simplify 2 over 9 in bracket raised to power negative 2 times 4 over 27. What do we do? 2 over 9 will become 9 over 2. And the negativity at the power level will disappear. Times 4 over 27. So, the meaning of this is 9 over 2 times 9 over 2. The meaning of this, 9 over 2 raised to power 2 means 9 over 2 in 2 places, times 4 over 27. So, let's break everything here. This is 9 over 2 times 3 times 3 over 2. This 9 I break into 3 times 3 times 4 over 3 times 9. I break this on purpose. I break it this way so that 9 be able to cancel 9. 3, be able to cut this 3. And we have what left? At the numerator, we have 3 times 4 over 2 times 2 is 4. We have at the denominator 2 times 2 times 1, so which is 4. So this 4, we take care of this 4. The final answer is 3. And that is it. Let's consider the last example I have for you under this. Example 4. Simplify 1 number 1 over 2 in bracket raised to power negative 3. I convert the number in the bracket to improper fraction. 2 times 1, that's 2, plus 1, that's 3 over 2, or raised to power negative 3. What does this mean? It means 2 over 3, as you have been taught. Find the inverse of 3 over 2, which will be 2 over 3, raised to power the positive power instead of negative. So, and this means 2 over 3 in 3 places times 2 over 3 times 2 over 3. That is 2 over 3 in 3 places. 2 times 2 times 2, that is 8. 3 times 3, 9. 9 times 3, 27. And that is the final answer. Let's have a break.